In section 11.1, we're going to talk about parabolas in a little bit different sense than we've talked about them before when we identify quadratic functions. So we found out that a parabola is the set of points in a plane that are equidistant from some fixed point F called the focus and a fixed line L called the directrix. So what happened was we did a little project where we put some point somewhere on a piece of patty paper and then we drew a line somewhere. We took our patty paper and we folded it so that the focus point lie on top of the line, the directrix. And let's see, directrix, I gotta spell it correctly. And we kept folding the paper so that that point lay on a different spot on the line. And every time we did that, we creased the paper. Well, what ended up happening was we got this parabola shape from all the creases. That's kind of neat. So let's talk about parabolas whose vertex is at the origin. We'll talk about parabolas whose vertices are somewhere else in another section. To get used to the conic parabola, we're going to just put the vertex on the origin. It's going to make our lives a lot easier. So the focus ends up being some point that lies on the inside of this parabola, while the directrix is a line that lies on the outside. And the directrix, I want you to notice, is perpendicular to the axis of symmetry, that line that goes down the center of the parabola and cuts the parabola in half. So this is our axis of symmetry, the y-axis. Now, the distance from the focus to the vertex is going to be the same length as the distance from the vertex to the directrix, and we're going to call that distance p. Now, although I've given you equations in the notes, those more have to deal with parabolas whose vertex is not at the origin. So for right now, let's talk about what it is when it is at the origin. When it is at the origin, the equation of the parabola is x squared equals 4py, because when it isn't at the vertex, or when the vertex isn't at the origin, it's at x minus h squared is equal to 4py minus k. That's really the difference. Since the vertex is at 0, 0, h is 0, k is 0, they kind of go away. So our vertex is at 0, 0. The focus is going to be at the ordered pairs 0, comma, p, because that focus happens to be on the y-axis, so its x-coordinate is 0, and it's p units up the y-axis. And the directrix, because it's below the x-axis, is going to be the equation y equals negative p. Now, if the parabola opens downward instead, so if instead it looks like this, the focus would be down here, the directrix would be up here, and the equation would be, for the focus, would be at 0, negative p, and the directrix would be y equals p. And the equation of the parabola would be x squared is equal to negative 4py. That would be the difference. Let's do an example. Let's find the equation of a parabola. Find the equation for the parabola with the vertex v at 0, 0 and focus f at 0, 2 and sketch its graph. Well, let's start by sketching its graph. If I sketch its graph, it's going to look like this. The vertex is going to be 0, 0. Since the focus is at 0, 2, the parabola must open upward, because the parabola is always going to open around the focus. So now for the equation x squared is equal to 4 times times y. P is the distance between the vertex and the focus. Well, that happens to be 2 units. So the equation must be x squared is equal to 4 times 2 times y. So x squared must equal 8y. And as I said before, since the focus is at positive 2, the parabola must open upward. And the directrix must be at y equals negative 2. Now let's talk about finding the focus and directrix of a parabola from its equation. Find the focus and directrix of the parabola y equals negative x squared and sketch its graph. Well, let's start with a sketch of its graph. That one's easy. Because it's negative x squared, the graph's going to open down. And the vertex is at 0, 0, so it's going to look something like this. So the focus must be inside the parabola. It must be at 0, negative p. Well, how do I find out what p is? Remember that the equation is x squared is equal to 4py. If you take that negative in front of the x squared, you can move it to the other side of the equation. So it's really x squared is equal to negative y. All I'm doing is dividing both sides of that equation by negative 1, which is acceptable. Well, I find out that 4p is equal to negative 1. So p must be negative 1/4. So the focus must be at 0, negative 1/4. And if the focus is at 0, negative 1/4, then the directrix must be at the equation y equals positive 1/4. Now you've spent a lot of time talking about parabolas that open up and down. What makes these conics is sometimes the parabolas can open left or right. So what happens if I want to talk about a parabola that opens to the right, or a parabola that opens to the left? Those are also parabolas. They also have foci. It's just that their foci is at p, 0, or negative p, 0. If it opens left or right. Because in this case, the axis of symmetry is going to be the x-axis rather than the y-axis. And if the parabola opens left or right, the directrix is going to be a vertical line. So the directrix is going to be x equals. In this case, it's going to be negative p, and in this case, it's going to be positive p. Oops, I should make that an x, not a y. And the equation that goes along with parabolas that open left or right is y squared is equal to 4px. When we talk about parabolas whose vertex is not at the origin, it's going to be y minus k squared is equal to 4px minus h. We'll come back to that in a later section. So if the parabola opens to the right, 4p is positive. And if the parabola opens to the left, 4p is negative. Now let's talk about a parabola with a horizontal axis. A parabola has the equation 6x plus y squared equals 0. Find the focus and the directrix of the parabola and sketch its graph. Well, sketching its graph can be pretty easy. If I draw myself a little sketch here, I know that this is y squared is equal to negative 6x. So if it starts with a y squared as opposed to an x squared, it's going to open left or right. How do I know which way it's going to open? Well, 4p is negative, so it must open this way. The next thing I need to figure out is what the focus and directrix are. Well, 4p is equal to negative 6. It's equal to that coefficient in front of the linear term. So p must equal negative 3/2. So I know the focus must be at negative 3/2, 0. Therefore, the directrix must be the equation x equals positive 3/2. In order to use a graphing calculator to draw the graph of a parabola that opens left or right, some of you may know that on your graphing calculator you can change that y equals to an x equals, but we don't really need to do that. One of the other ways we can do this, or the other way we can manipulate this equation so that we can solve it, is if you do this. So we know that y squared is equal to negative square root of x. To get rid of y squared, we take the square root of both sides. But when you do that, you have to make the positive square root and the negative square root. If you graph one of these in y1 equals and one of them in y2 equals, it'll show you both halves of this parabola that opens to the left. When we draw a line from the focus to some point on the outside of the parabola, this length here is called the latus rectum. Now we know that this distance here is p because it's the same as this distance here, because it kind of makes a rectangle. Well, the latus rectum ends up being the absolute value of 2p, approximately. And this entire length here, from one side of the parabola to the other, that passes through the focus, is called the focal diameter. And the focal diameter can be used to estimate the width of a parabola. So let's find the focal diameter of a parabola. Let's find the focus, directrix, and focal diameter of the parabola y equals 1/2 x squared and sketch its graph. Well, let's start with the easy part. Let's sketch its graph. Since it starts with y equals 1/2 x squared, this is going to be a parabola that opens either up or down. Well, 4p is positive, so it must open up. So I know already that the parabola is going to look like this. All right, next, let's find the focus. Well, if this is y equals 4px squared, then 4p must equal 1/2. So p must equal 1/8. All right, let's try that again because I goofed it up. This is 4py is equal to x squared is the equation that we used earlier, and I don't want to mess you guys up. So that 1/2 that's in front of the x squared, if I get rid of it, it becomes 2y equals x squared. So now 4p equals 2. So p is equal to 1/2. Sorry about that. I am human and make mistakes just like everyone else. All right, so p is 1/2. So I know that the focus is at 0, 1/2. The directrix must be at y equals -1/2. Okay, so now I know the focus and the directrix. Now the next question is, what is the focal diameter? That means, what is this length here? Well, half of that length is the absolute value of 2p. Well, 2 times 1/2 is 1, and the absolute value of 1 is 1. So the latus rectum over here must be 1, which means that this is 1, which means that the focal diameter must be 2. And notice that at the very beginning I made a mistake. I forgot to make sure that the term with the square was isolated. Don't do what I did. Make sure that your term that's squared is isolated before you go and determine what p is. Let's talk about a family of parabolas. Find equations for the parabolas to show how changing the distance between the focus and the directrix, the focus and the vertex, affects the width of the parabola. So I give you 4 foci here. Foci is the plural of focus. And the first thing that I want you to notice is that the focus has a 0 for the x-coordinate, which means that the parabola is open up or down. So the equation that we're going to use is x squared is equal to 4py. That's the equation for parabolas that open up or down. Well, if the focus is at 0, 1/8, that means p is 1/8. So x squared is equal to 4 times 1/8 times y. Here, x squared is equal to 4 times 1/2 y. In the next one, F3, x squared is equal to 4 times 1 times y. And in the last one, x squared is going to equal 4 times 4 times y. Now, if I wanted to graph these in my graphing calculator, I would have to graph 2x squared, 1/2 x squared, 1/4 x squared, and 1/16 x squared. So this value in front of the x squared is going to change the width of the parabola. This is going to be a very narrow parabola if you were to graph it in your calculator. And what you're going to find out is that this one over here is an awfully wide parabola compared to the 2x squared. So changing the location of the focus changes the width of the parabola. Parabolas have an important property that makes them useful as reflectors for lamps and telescopes. Light from a source placed at the focus of a surface with parabolic cross sections will be reflected in such a way that it travels parallel to the axis of the parabola. So if I have a parabola shaped like this, and this is where my focus is, light that hits this. So if we consider the focal point, let's go back to this. If this is where the light source is from, when the light source reflects out and hits the parabola, the point where it hits and where it reflects off is always going to be parallel to the axis of symmetry, which is kind of the way that a flashlight works. So if a searchlight has a parabolic reflector that forms a bowl shape, so like this, and we know that it's 12 inches wide from rim to rim, so this is 12 inches, and 8 inches deep. So from here to here, we would say it is 8 inches deep. If a filament of the light bulb is located at the focus, so if there's like some light bulb here, how far from the vertex of the reflector is it? In order to do this, we're going to introduce a coordinate system. So I'm going to make a coordinate plane here. We'll say that the vertex of this parabola is at 0, 0. And we said this bowl is 8 inches deep. So this point here is going to be at 6, 8. Why is it 6, 8? Because if the diameter of the light bulb here is 12 inches, then half of it must be 6 inches. And we said that it's 8 inches deep. Since the parabola opens up, we're going to say the equation of the parabola is x squared is equal to 4py. Well, I have a point on the outside of the parabola. It's 6, 8. So 6 squared is equal to 4 times p times y is 8. So 36 is equal to 32p. So p must be 36 over 32, which reduces to 9 over 8. So if p is 9 over 8, then the focus must be at 0, 9 over 8. So that's how far away the vertex is from the reflector. And that's section 11.1 on parabolas.